Good. So I think Luke is ready now. We're going for the second shot. Please, just give some support to Luke because, he felt a little bit stressed with all these things. I think his heart is still, bumping fast. Let's bring him to the stage again. And I hope that he has changed his tea with beer because I think it will run much smoother if you have beer on your cup now, not tea. Come on, Luke.
Well, I think the caffeine in the last talk definitely didn't help the heart rate, but
Okay. Look, I leave the stage up to you. Do you want to share now to see if it's going?
Fingers crossed. Daniel created an entire new event to test this thing, so I have to share my entire screen now, so you get this. All right, cool. And I can't see you guys anymore. Let's just go. All good? Can you see Pedro?
I can see it. Try to change it.
Let me change.
Change the slide, I mean.
Yeah. So I'll change the slide. Yeah.
Yeah, it seems working.
And change the window.
Wow, amazing.
Beautiful.
It's working. It's working. I'm going to leave you. Have fun.
Okay.
Bye-bye.
I'll start. All right, guys. I'm the only talker that gets a second attempt, so thank you for bearing with me. I'm here today to talk to you again about blockchain fundamentals and why it's not just for Bitcoin. I think I'll be dialing the technicalities down a little bit from the previous talk and really just diving into the core of what a blockchain is and why it's such a big shift and what all this noise about blockchain is. And then at the end, we start to get a little bit more technical and try to give you people a leg up on how they can start developing for the blockchain. So the blockchain's come a long way. It's kind of hit its adolescence at this stage. If you kind of look back through the history of what led up to the blockchain, there are some early papers in 1991 around kind of time stamping and digitally stamping different files. And then moving into the early kind of noughties, the early 2000s, we have some early primitive attempts at, digital cash and bit gold and things like this. That was the kind of era of Nick Szabo talking about kind of smart contracts. And, then in 2008, Bitcoin arrived, the Bitcoin paper by Satoshi Nakamoto. And in 2009, we were getting the first Bitcoins. And we've come a long way since then in that 12 years. So this is the hype cycle from Gartner in 2019. You can see kind of Bitcoin hit this trough of disillusionment in 2019 with a prediction that in 2 to 3 years, it's going to start becoming really useful for businesses. One thing before I move on from this slide is just, so there's a lot of technologies in a lot of different industries, kind of a bit further back in the curve, but you can just see how many different industries this is going to kind of hit. So right at the top here, we kind of got smart contracts and blockchain in insurance, and blockchain in education. And then back here, we have blockchain for customer service, blockchains for advertising, that's like really early on in its development. So it's going to hit so many different industries. I've just stolen this quote here quickly. Why blockchain matters to CIOs, chief information officers. Again, it's from Gartner and the references at the bottom there. But Gartner estimates blockchain will generate 3.1 trillion in new business value by 2030, with the technology set to be ready for more mainstream adoption through 2023. Organizations should be exploring the technology now. So one of the most respected kind of thought leaders and trend analyzers in the business is kind of suggesting now is the time. So that leads us on to the question of what is a blockchain? I tried to think of a very simple way of explaining what a blockchain is, other than a chain of blocks. And Wikipedia offers a blockchain. Originally, blockchain is a growing list of records called blocks. They're linked using cryptography. So that's a very kind of simple, in a sentence, definition of a blockchain. That might not help you visualize it or see how you might adopt it or what you want to use it for, or why the magic. That doesn't make you think, right, this is something that's going to generate trillions in revenue by 2030. So some of the properties and some of the things I've extracted from different definitions that you'll find around on the web is how highly fault tolerant it is, verifiable and auditable but not editable, date stored in time-stamped chronological order, highly cryptographically secure, append-only transactional data store. And these technical terms, they sound cool in the academic papers, etc. But again, it makes it a bit tricky to kind of visualize where the benefit's going to be coming from, or just how revolutionary this is. So some of the questions that I pulled from all of that and what I wanted to demonstrate to you guys today is, how are these links formed? What's inside of a block? How are these blocks linked? And what's this thing to do with distribution and decentralization? So now this is the bit that didn't work earlier. So to understand the cryptographical aspect of a blockchain, we're going to use this tool. Just a shout out to Anders94, who's made this tool available. This is his GitHub repo here. I really recommend you go pull it down and have a play around. You can stick it on your website if you'd like. So this tool is used in quite a lot of different demonstrations because it really helps to visualize what happens with a blockchain. So a SHA-256 hash, a secure hashing algorithm, 256 bits, allows us to basically create a digital fingerprint of any data. So I can insert a word here, hello, and you can see down here we've got a 64 characters that represents this word uniquely. If I was to do something as small as put a hello space in there, you see we get a drastically different hash. It's also worth pointing out that this hash is a one-way hash, so we can't take the hash and then work out what the data was. And we'll speak about why that's important later. So you could put an entire movie, an entire book in here, and it will always condense it down into a very unique 64-character hash, which will uniquely represent all of that data. Now, that explains some of how they're cryptographically linked. So moving into how that's used and what's actually within a block. Here we have a slightly simplified block for you. And you'll see some of the things that are kind of kept within these blocks. So we'll have a block number. So it's an append-only, a blockchain is an append-only data structure. So you'll have your first block, the next one will be your second block and your third block. And sometimes these will start with zero-based arrays, or, you know, this one's starting with a number 1. The first block's slightly bit different, and we'll call that the Genesis block, and we'll get to that one later. So here will be the data, and we can come up with a transaction like Sally owes Sam £5 or something like this. Let's make it cents. And we can see down here that that's created a unique hash for us, which was representative of the block, the nonce, and the data. And if we change any of these things, we're going to get a drastically different hash. Now, of course, we can't change the data within a block because that would be, you know, we don't want to change the data. We want to keep the recipient and the sender and the amount the same. We don't want to change the block number. So this is why we have this variable nonce, which actually stands for number used only once. And we can change this. And if we change this, you'll see we'll get a drastically different hash each time. Now, the way that blockchains work is, or this is all based off the Bitcoin blockchain, by the way. It's the most widely studied and the kind of core blockchain that's inspired a lot of these other blockchains. So it makes sense to look at that one first. But the way that works, we'll have miners all over the world competing to validate and verify these blocks for us. And in return, the first ones that will validate and verify these blocks before adding them to the blockchain will get a reward. Now, the way to slow them down, so they're not all just doing it in seconds and milliseconds, is they have a cryptographic puzzle. And solving this cryptographic puzzle and validating the blocks, etc., we call mining. Now, mining is a puzzle which is basically trying to generate a certain hash, which meets a certain criteria by changing the nonce. Now, we want to, basically, in this example, we want to have 4 leading zeros. So if we could get 0, 0, 0, we'll have a valid hash. Now, I'm just going to click mine here, and there we go. So for this particular one to be a valid block, according to our agreed difficulty level of 4 zeros, we need a nonce of 5190. If I was to put a space in here, you'll see it's now invalid. It's generated a new hash, so we'd have to mine the block again. And hope my browser can handle it. It might be a bit of a big number. Okay, cool. So you'll see that's a bit of a bigger nonce. It's kind of had to go through 168,000 different numbers there to find a hash that's starts with 4 zeros based on that. So that's essentially what a block is. In a real blockchain, there's a few other different fields and things that we can get onto. So then how do these all link together? Well, it's a bit like a linked list. So they're always going to keep a hash. Each block will keep the hash of its previous value. Of the previous block, sorry. So this block here has the hash 00157, and then this second block, block number 2, has a link to that block. Why is this important? Because if someone was to maliciously kind of take a block, keeping the example of Sally and Sam again, and she turns around and she goes, Sally owes Sam only £1. She's trying to make £4 out of this. You'll see it's broken the hash on this one, but because this hash is now no longer valid, it doesn't evaluate to 4 zeros. It's broken this one, and it will break the entire chain. So that's how it's linked. If you make a change to one block in the chain, you'll then have to then mine and remine every single block. Again, it might take a little bit of time to make the blockchain valid again. Now, this doesn't really make much sense to save your £4, and it involves a lot of computing work, because in reality, the blockchain it needs something like 18 leading zeros, and I think the chances of getting that, you're much more likely to accurately guess the lottery numbers than to get the nonce right on your first attempt. So, but if we were to make this £1 million or something like that, it might be worth all the electrical energy fees. It's not unusual that professional mining companies will spend, tens of thousands of pounds on electricity every day to just running computers trying to solve these cryptographic puzzles, so they can be the first to validate the latest block in the blockchain and to win the reward. The current reward for a Bitcoin blockchain is 6.25 Bitcoins plus the transaction fees for that block. So as you can imagine, if you were to successfully win that cryptographic puzzle, you would be a very, very happy man or woman. So that makes sense. So in this case, Sally's been able to say, change numbers drastically, or I think Sam benefits here if Sally sends him £1 trillion. So this leads us on to why do we distribute a blockchain? So this introduces trust into the system. No one person can start doing these things, keeping $1 trillion for themselves, and then also saying they're sending $1 trillion and introducing things like a double spend, spending the money twice. If peer B was to make a change and was able to manage every single successful block, like so, it's going to be another big one. You can now see when they're going to be, once they've successfully mined this last block, they will basically broadcast it to the blockchain network and all the other peers on the network. And you'll see that this peer B is ended with a very different hash, 0C, let's make sure that's scrolled to the end, EC4, to what the other peers on the network have ended with, 217C and 217C. So A and C are in an agreement, and peer B is not in agreement. And part of the kind of Bitcoin protocol is you'll have these different consensus protocols, which is how you'll agree if, for example, two people successfully validate a block at the same time, or if someone's broadcasting an incorrect chain which doesn't match up with their own chain. And part of the beauty of it is that it manages to establish trust on these transactions without any intermediary parties, just through these use of hashes. I'm not going to go too much further into this tool, but you can actually see that, as I said, the data actually contains many transactions. So it's not one block per transaction, but you can kind of play around in here if you were to go get the tool yourself or to find it online. and see that actually it will contain many transactions. And it will also contain a Coinbase field. And this Coinbase is essentially, as part of the block, it will go, Anders here is essentially getting his £100 fee plus the transaction fees for successfully validating this. So hopefully that's given you a bit of a visual thing of what a hash is, what's contained in a block, how these blocks are then chained to each other, and how if you change one, you're going to break the chain of blocks. And then how by distributing this around the world and having all these different miners validate and compete to win that future block, and then agreeing amongst themselves whenever there's a dispute raised, it's created this blockchain. And up until Satoshi Nakamoto did that in 2008 and 2009 with his Bitcoin paper, this kind of enabling these kind of financial transactions in a trusted way without something like a PayPal or a bank in the middle, or we could easily put house data in here and kind of transact houses without the need for an estate agent. There's lots of different benefits to doing this. So if I switch back to my slides, cool. So not all blockchains are necessarily public. You can have permission blockchains and conglomerate blockchains. The Bitcoin blockchain is very public. So you can actually go onto blockchain.com or some other blockchain explorers and take a look at the latest mined blocks. And you can see here, for example, the timestamp. So they adjust the difficulty. So at the minute, like I said, it was 18 zeros. So you can see the hash that they actually had to find. And the computational power to actually find this many zeros of a hash is mad. Like you can see the difficulty level here. And we can also see for example, the nonce, what it eventually came up with, how many Bitcoins were transacted, the rewards, the fees. So there's lots of things going on there. And this is a really cool website where you can go play around and get used to seeing different blocks and what they contain. Cool. So that's great. We've managed to revolutionize the finance industry, and that already had many banks and related industries scrambling, and governments trying to introduce legislation because they didn't see this coming. And it really has kind of shook those kind of industries. And I think PayPal this year has started accepting, or will start accepting, blockchain Bitcoins on its own network. But the point of this conversation today is to really understand what's next. Bitcoins, they came around 12 years ago. Them themselves aren't going to change every single industry. So what else can we do with blockchains? So one of the most popular things is smart contracts. So someone came along and basically said, what happens if we store executable applications or code within these blocks as well? So not just data. Why are these called smart contracts? Smart applications or something like that, because they enable contracts to essentially be executed, and we can represent these contracts in code. So basically in the formula, if these conditions are met, then do this. So this will allow for completely auditable, public and decentralized applications. And again, something like this hasn't really been available, where you can publicly post out these contracts or post out this code and only get it to run under certain situations, when certain triggers are met and in a fully trusted manner. It is worth pointing out that Bitcoin does actually have something called Bitcoin script, and there is a limited amount of code and messages that you can kind of put into Bitcoins. But this is very kind of limited. The Bitcoin creators didn't want to introduce loops into their Bitcoin script for the reason that, if we're running these scripts and all of a sudden someone's got an infinite loop in there, how's the blockchain going to handle this? Is it going to kind of hold up the entire blockchain? Is everyone going to be running loops and stuff on their machines? So it's not a Turing complete language, and you can't run every single type of application under it. So this is something that I borrowed from down here, the developers documents for smart contracts from Ethereum. Now, Ethereum is a completely different protocol that kind of runs on blockchain technology. So it's very different to Bitcoin. And again, this Nick Sarsbo has kind of come up, who is one of the core figures around what smart contracts are. And his example here is it would be very simple to kind of just have some code within a block, which would basically go, do we have the money? Do we have a snack selection? Then run some code to dispense a snack within the Ethereum blockchain. So here's just another visual demonstration. So earlier we kind of showed you the 4 empty blocks. Well, now we've got the 4 blocks that are all connected together. The first few are containing data. And then this symbol in the last few blocks is for Solidity. And Solidity is the programming language, which is suspiciously similar to JavaScript. You're either going to love it or hate it, which can be executed within Ethereum blocks. Now, if we go back to this graph here, we can see that a couple of years ago, smart contracts were right at the peak of these inflated expectations. And so now, a few years later, they've come back down. And smart contracts are, again, expected to be an absolutely huge part of what blockchains are doing moving forwards. From, as previously mentioned, even just kind of estate management, managing artworks, and who owns what as well. So even further back in that hype graph, so it's still in the early stages, we have this concept of a DAO, or a decentralized autonomous organization. Now, these things, again, have the potential to be incredibly revolutionary. And if we have a traditional organization that works with many different people, kind of doing manual transactions, somebody comes in, they'll stamp their time card, the receptionist might give them some letters, and they'll go to their computer and they'll put some money in a vending machine. These are all very manual things. Modern organizations have already started to enhance that with software and automate a lot of these things. There's no need for stamping time cards and stuff these days. A lot more stuff is automated, but we could potentially take this even further and switch out any transactions with smart contracts. So where we have these triggers, if this and this happens, then do this. We could store the code in these smart contracts for these different transactions within a blockchain, and we could completely decentralize. We could almost remove the need for an organization. It could almost run itself in a very trusted way. So this is a very, very hypothetical example that I came up with. So my day job is a software engineer for a supermarket client. And potentially 10 years down the line, we could have something that looks like this. So we could have a self-driving automated car in the middle. And we could have certain smart contracts that are triggered at the different points of this kind of vehicle's job. So its job's going to be to basically go to the farm, ensure the farmer gets paid, pick things up, go to the power bank when it needs recharging, and then drop things off at a warehouse, pick things up from a warehouse, and deliver them to an automated shop. So you could easily imagine the triggers that could happen with the farm. So, if the car is at this farm and it is loaded with this, pay the farmer this amount of money and get the car to drive to the warehouse. And you could almost remove any kind of centralization or governance here. You wouldn't necessarily need an organization or a traditional company to run the car. It could just drive around in its own self-automated kind of way, be a nice little Tesla or something. You could remove the need for banks. You wouldn't need kind of HSBC or someone to sit in the middle, because you could just be transacting in something like Bitcoin and just be saving it to cryptocurrency wallets and just putting the money straight on the blockchain. The farmer will be putting a transaction on the blockchain saying, give this car £500 and vice versa. And you could very easily see how this car could almost go about itself, just kind of having these smart contracts and these automated triggers The interesting thing as well is that it's also kind of become extensible. So if the car can kind of charge itself and go between farms itself and deliver things itself, what's stopping it when it gets, so much cryptocurrency in its crypto wallet to buying another car and just expanding the thing? And it's a really interesting thought experiment that you could run a whole kind of ecosystem in a fully automated manner. Now, it seems very, very, very far-fetched until you start looking that with a combination of machine learning and artificial intelligence, we've already got vehicles that can go to a takeaway and pick up a takeaway and drive it to your house. I had a colleague the other day on a Zoom call that was showing me something that looked very, very similar, delivering something from his local co-op, his lunch. And then in London, we've had these, we now have these Amazon grocery stores, which are basically checkout lists. It will use a variety of different technologies to detect what you're picking up and taking off the shelves and putting in your basket. And based on using some smartphone technology, it will automatically bill you as you walk out the shop. So you can see how we can take these technologies and through the imaginative use of the blockchain, where you could start to even automate these things even further. So I did mention earlier Ethereum and Solidity. Now these are friends with Bitcoin, right? These aren't in competition. Bitcoin's there for finance and for transactions without using, traditional fiat currency. Ethereum is there solely to kind of run code in a distributed way. And I mentioned a couple of issues earlier. One is Bitcoin didn't want to do it because of the extended loops. What happens if you get code that takes ages to run? And the second issue as well is what happens if you're distributing viruses on this network? All these miners are downloading your code, trying to verify it and run it for you. What's stopping you very, very quickly just taking out all of the miners' machines? So Ethereum's been really, really clever about this. And they're topics where if you want to start developing on the Ethereum blockchain, I really, really encourage you to go and take a look at the developer docs. The link is down here. But just so that you can kind of get an understanding of how this stuff works, Ethereum will charge gas. Now, gas is a unit that measures the amount of computational effort required to execute specific operations on the Ethereum network. So an addition might be 1 unit of gas. To stop an application might be 0 units of gas. To kind of create a smart contract on the Ethereum network might be several thousand units of gas. So these are things that people are going to have to pay with in the Ethereum cryptocurrency. So it makes sense to make sure that you're not running loops, or very, very quickly you're going to have a big bill to pay. And you have to pay up front as well. So it's not like they can be chasing you down for the money. Also, we have this concept of an Ethereum virtual machine. And this is really similar to a Java virtual machine. And if you're an Ethereum miner and you're a node on the network and you're downloading these Ethereum blocks and checking these smart contracts and running code that needs to be ran, trying to win the Ethereum reward, then you're essentially going to run it in this Ethereum virtual machine. This keeps their files and their code separate from your code, your files and your code, and it makes it a very safe space to execute these codes. Yeah, it's really interesting. So I do quite a few interviews for Mindera, and one of my first interview questions, and this is a hint for anyone who might be looking for a job with Mindera following on from these talks, but why does clean code matter, or what does clean code mean to you? And the answer to that, if you're an Ethereum developer, is because it can get very, very expensive very, very quickly paying out these gas fees in Ethereum. And this is just an example of some gas costs for different operations that you might need to do within the Solidity framework. And so as you can see, contract creation down here is 53,000 units of gas, which is similar to, I think an addition is basically costs 1. I think a multiplication costs a few additions because obviously it's a bit more computationally expensive. So it's going to create very clean and very performant code, which is good and healthy for the network. So I've got a couple of minutes left. I just want to give you a bit of a heads up on how to kind of move forward with development here. We've kind of talked in relative detail or given a bit of an overview of how Ethereum works, the JVM and gas fees and the Solidity framework. I only have half an hour, so I can get into any actual coding. But this can get quite expensive developing, and you're based on the Ethereum network, which is very generalized. Hyperledger is a massive project that's been contributed to by many, many technological giants. We're talking Intels and IBMs. And again, if you're a Java developer, it's very similar to the Spring framework. There's lots of different projects and tools available, which you can kind of pull together to create your own very, very industry-specific blockchain. And this is being used to great success at the minute and is a very, very active project. And then stepping away from the kind of dedicated kind of blockchain application type things, if you're looking to get involved in development or to do some code, the first kind of blockchain code that I was writing was in Java. I like to call it mockchain because it wasn't real blockchain code. But you can start to build these kind of proof of work and consensus protocols in Java and try and replicate the logic and stuff and build something very, very similar to a blockchain in your standard favorite language. It could be Python or Node or JavaScript. And yeah, so that was a great way that I kind of picked it up and learned. And then, of course, Golang in the corner. I've called that one specifically out. A lot of these frameworks and a lot of these cryptocurrencies are utilizing the Golang, the Go language, because I presume because of its ability to be so concurrent and distributed. So just calling out a couple of use cases. This one I pulled up because I specifically read it this week. So 2 British hospitals are using blockchain technology to keep tabs on the storage and supply of temperature-sensitive COVID-19 vaccines. So this is stuff that's being used. It's actively developing, and hopefully it's helping to save lives. If you want some more specific cases about Hyperledger examples, you can go into the Hyperledger documentation, and there's loads of use cases. This is an open source framework, so I'm not trying to sell anything here. You can go away and start creating Hyperledger code free for open source. But what's interesting in this screenshot is I've just picked 3 random examples, and you can just see the industries. We're hitting mining industries, supply industries, food industries, agriculture, supply chain, commercial goods, real estate. So there's many different applications to these very specific properties that the blockchain offers. I'll share these out as well. I'll put a link to it in the chat following on from here. And I'll also put it on my LinkedIn. And these are some very useful things that I'd encourage people to go away and look into if they wanted to learn a bit more about blockchain, how it works and how to develop on it. So I hope that you've learned how blockchain is so much more than Bitcoin. And I think I've already made a mistake here. It's not has the potential to be a major disruptor. It's already started, and it's going to continue, and it's going to build momentum. And I think as technologists, depending on whether you're a half glass full or half empty kind of person, we can be cautiously optimistic or optimistically cautious. And my friends and colleagues wouldn't forgive me if I didn't get an animal GIF into my slide decks. I use great restraint, but this is just a cat showing some curiosity and putting his ears up and at least having a look around and diving into it. But thanks for watching. If you bared with me on the first attempt, I'm glad you made it through to the second attempt. I'd really love you to reach out to me on LinkedIn or on email, luke.punnett@mindera.co.uk, and I'd love to dive deeper, show you some examples of Hyperledger code or talk about Solidity. Thank you. And for a laugh, this was me selling my 0.1 Bitcoin for £75. Cheers. Is Pedro there?
Yes, I'm here. Sorry, I was a little bit emotional when you shared this Bitcoin part. I was, I even lost my voice.
Oh, no.
Look, thank you so much. You were a warrior in this presentation. You did it. Huh? And you even managed to put a cat at the end. It's like you just win the audience just by that. They forgot about everything. It's like, there is a cat. Come on. Blockchain and a cat. It's like amazing.
I know. Winning combination.
What a combination. Very good. Look, it was a pleasure. Thank you so much.
Awesome. Thank you.
Bye-bye. Thank you.